Hi friends, welcome to my YouTube channel. Today we are going to discuss about foundation, basics of foundation, types of foundation, and we'll learn first what is a foundation. A foundation is a part of a structure which transfers the load of the structure to the subsoil. And a foundation is also an interface between the superstructure and soil beneath the foundation. Coming to the classification, the foundation is subdivided into shallow foundation and deep foundation. And this deep foundation again divided into two types. Okay, coming to the shallow foundation, we are saying df by b less than or equal to 1, where df is nothing but the depth of the foundation. That is, see here, this is the ground level, this is the foundation, which is an interface between the superstructure, that is the structure above the ground level, and soil below the foundation. This is the foundation, right? So whatever the soil present beneath this foundation, it will transfer the loads to that. And df is nothing but depth of foundation, that is from the ground level to the lower portion of this foundation. This is df, where b is nothing but the base width of the foundation. The df by b, if less than or equal to 1, it is shallow foundation. Whereas the deep foundation, it is again subdivided into moderately deep and deep. The moderately deep is nothing but where the df by b value is greater than 1 and less than or equal to 15. And it is subdivided as deep foundation when the df by b value is greater than 15. Okay, this is the classification of the foundations with respect to the height or the depth of the foundations and width of the foundation. This is the ratio by which we are dividing this. Coming to the introduction part, foundations and structures placed on the surface of the earth will provide stresses in the soil. These stresses will decrease with the distance from the load. How these stresses decrease depend upon the nature of the soil bearing the load. Okay, we are just talking about the stress distribution. Stress initiated because of the foundation load and also the structure, the superstructure that is placed on the surface. Okay, so that's all the loads will cause some stresses in the soil. These stresses will be transferred to the soil beneath the foundation by the nature, like it depends upon the nature of the soil and the bearing capacity of that soil. Okay, I have told you the classification of shallow and deep foundation according to the depths, but we also have some other classification wherein because of the design we are dividing the shallow and deep foundations into the sub classification. They are in this way. Here the types of foundations are divided into shallow and deep foundations, wherein the shallow and deep foundations are again subdivided. In shallow foundation we have spread or isolated footing, strip footing, combined footing, strap or cantilever footing, mat or raft footing, grillage foundation. Whereas the deep foundations are subdivided as pile foundation, well foundation and pier foundation. We will see the explanation about this in our upcoming videos, but as this is introduction, I am just giving it the names of this. Okay. Next, we'll also discuss about how the stress distribution is going on in soils. As I told you, the stresses in soil can be caused because of this stresses in the soil due to self weight, also this surface load. See, the soil will itself have some self weight, right? And also the surface load because of the superstructure and also because of the foundation. There will be some stress developed in the soil. See, coming to the stress distribution in soils, we have geostatic stresses and added stresses. Added stresses are due to the loads acting. Whatever the loads, that is a point load or a strip load, triangular load, circular load or rectangular load. See, whenever we are talking about rectangular load, we have some methods. We have some Bosniak's method, Westergaard's method and also some approximate methods to deal with this rectangular loads. Okay, when I am saying the Bosniak's theory, we have also the point load, line load, strip load, triangular load, circular load and rectangular load. This will be evaluated again by the Newmark's chart. Okay, and coming to the geostatic stresses, we have three, that is total stress, which is a summation of effective and pore water stress. Okay, initially we have three types, that is total stress, effective stress and pore water pressure. Okay, yes, this is the diagram of how it is represented. And also along with the Newmark's chart, we have some influence charts and stress bulbs. This is just the diagrammatic representation and all the introduction part required for that. As I already told you, we will have some stresses due to self-weight. Stresses in a layered deposit. The stresses in a deposit consisting of layers of soil having different densities may be determined as the vertical stress at depth Z1, vertical stress at depth Z2 and Z3. See, whenever we are talking about a soil medium which is having three different types of properties, they will have different densities. So depending upon the densities, even the capacity to take loads will vary. So we will have to determine the vertical stresses at every depth individually. See, let us think these are depths Z1, Z2 and Z3. Okay, so we are calculating the stresses at varying depths. Okay, as the density is varying, also the vertical stress at that depth will vary. Okay, next we will also see what is the geostatic stress. The geostatic stresses are the stresses developed due to self-weight of the material. Okay, when the ground surface is horizontal, the stresses due to self-weight of soil are normal to the horizontal and vertical planes, and are no shearing stresses on these planes. See, whenever the loads are vertical, there will be no shearing stresses. Okay, when the load is vertical, we will have no shearing stresses, but whenever it is inclined, it will have some theta, that is again the twisting moment, which will cause some shearing stresses on the plane. But here in this case, we only have the self weight which is normal in the direction to the horizontal and vertical plane. Okay, and whatever the planes we are talking about are called as principal planes, are the principal planes. In the geostatic stresses, we have types. We have vertical stress and horizontal stress. They are, so the vertical stresses at a depth Z below the ground surface due to the self weight of soil is given by sigma Z. This is the vertical stress at a depth Z. Okay, we are evaluating the stresses due to this load at a depth Z. Okay, here the sigma Z is equals to gamma into Z. Sigma Z is nothing but the vertical stress at depth Z. Okay, as shown over here. What is Z? Z is nothing but depth below surface. I already told you this is the ground surface we take as the origin. Okay, so from this, whatever the depth at which we are evaluating the stress is Z. And we also have gamma. Gamma is nothing but the unit weight of soil. Okay, gamma is unit weight of soil. Simply the sigma Z is equals to gamma into Z. We know the units of gamma, that is, we know the stress is in units kilonewton per meter square, and we know as Z is depth, it would be in meters, but we are also multiplying it with this. So we know the units of gamma, the self weight, gamma is unit weight, that would be kilonewton per meter cube. So this meter cube, a meter would cancel with meter square, so this kilonewton per meter square. Okay, so these are the units for stress. Next, coming to the horizontal stresses. The horizontal stresses at any point in a soil mass are highly variable. Okay, we are talking about the stresses developed because of the load in the horizontal direction. The horizontal stresses is given by sigma x is equals to sigma y is equals to k naught into sigma into z. See, sigma is nothing but the The sigma z is nothing but the this vertical stress. So the vertical stress when we are evaluating the horizontal would also be evaluated. Firstly, the sigma z is evaluated and that is multiplied with some factor to get the horizontal stress. Okay, the vertical stress is multiplied by some factor to get the horizontal stress. That factor is represented as K0, where K0 is the coefficient of lateral earth pressure at rest. Okay, K0 is the coefficient of lateral earth pressure at rest. We know the units of sigma z as kilonewton per meter square. As K0 is a constant, it will not have any units. So it is simply sigma x is equals to K0, that is no units, into kilonewton per meter square. So it is simply kilonewton per meter square. We got the units over here again. So the vertical stresses are due to self weight and increase with depth. Okay, there are three types of geostatic stresses. As I already told you, we have three types, that are total stress, effective stress and pore water pressure. Whereas the total stress is summation of effective stress and pore water pressure. Okay, the total vertical stress is nothing but the effective stress plus pore water pressure. See the notations of this is nothing but sigma total, whereas the effective stress is notated as sigma dash and pore water pressure is nothing but u. Okay, this is the formula. Total stress sigma is equals to sigma dash plus u. That is it for this video, guys. Please like, share, comment to my channel. Please subscribe to my channel. That would greatly help me. I appreciate you watching this video. Thank you.